In this video, we are going to talk about how to make right decisions based on present worth analysis. So many times we have multiple choices or multiple alternatives to select from, and we have to select the best alternative, the most profitable alternative. So in those cases, what we can do is we can analyze each alternative from the economic point of view. We can calculate if there are cash flows involved. We can calculate the present worth or present value of the cash flows for each of the alternatives, and the alternative that gives us the highest present value or highest present worth is the most profitable alternative, right? And that's the one we choose. So we have a problem here. Let's read the problem first and then try to analyze it and select the right choice. A firm is considering the purchase of a new machine to increase the output of an existing production process. Of all the machines considered, management has narrowed the field to the machines represented by the following cash flows. So, this particular company is, let me make it bigger here. This particular company is trying to buy a new machine to increase the output of an existing production process. So they have, after given it a lot of consideration, they narrowed down their choices to these five machines that are documented in this table. And we have some cash flows associated with each of these alternative are given. And now we our job is to choose if I will read this further so you understand. If each of these machines provides the same service for 3 years and the maximum at minimum attractive rate of return is 12%, which machine should be selected? Okay, very interesting. So minimum attractive rate of return is given, which is 12%. That means uh, the investment that they are going to make in this any of these machines, that should at least yield minimum attractive rate of 12% on their investment. If it yields less than 12%, then the company is not interested in those projects. So 12% and higher is what they are looking for. Below that, they are not going to take risk and they are not going to take on the project. So far so good, right? So we know the minimum attractive rate of return, we can call it later I, 12%. We also know that each machine provides the service for 3 years. So time period which we use later n to indicate time periods, so that n is equal to 3, or 3 time periods. Analysis time periods are 3. I, interest rate or minimum attractive rate of return, is 12%. And then we have some cash flows for each alternative that are shown. Initial investment in each machine. So that's a negative cash flow, because we are going to spend that money to buy the machine. So machine one, initial investment or the cost of the machine, initial cost of the machine is $50,000. Machine 2 is $60,000, and so on and so forth. So looks like machine 5 is the most expensive with $100,000 initial investment, right? So that's just one number. Those are all minuses. Then each machine is going to yield uh, annual operating income of 22, some annual operating income, right? These are the investments, initial investments, that are going to be negative. And these are the, so these are p values. These are because they are in current time period. They are in current time period. They are already in the present value, right? Already present values, time period 0. And these annual operating incomes, those are A, because this is the same amount every year repeated, right? So it is indicated by letter A, annual operating income. So that's positive. This is negative. So we have each machine has different cost and different annual operating income. So if we First of all, we can see if there are any obvious choices. For example, if and since we are going to use only for 3 years, if we have any alternative that has annual operating income times 3 for 3 years, less than the initial investment, or equal to initial investment, then those alternatives are the common sense. We should delete them, right? Because they are not even recovering your initial investment, or they are no profit, no loss if they are in recovering initial investment. So all those outcomes, we don't need to do any further analysis. We can simply strike them out and move on. But I don't see any obvious choices here. So we will have to do further analysis. So let's calculate the present value for the entire cash flows, right? This is already present value. I talked about it, but this is A, and we need to convert that A value into its equivalent P value in time period zero. So we can then add these the equivalent P value of these and this P value. We can add them to find out the total net present worth. So here I have summarized them, the table in a different format. Initial investment is all negative numbers, so I put them negative. Annual operating income, which is letter A, we need to multiply that by P given A factor to convert that A value into its equivalent P value in the same time period zero, right? So we need to multiply that by P given A factor, 12% interest rate, minimum attractive rate of return 12%, and n is equal to 3, time periods 3. So let's look at what is the value of this factor, uh, and then we can multiply each of these numbers by that factor, right? So compound interest tables, you can Google them. This one is for 8%, but we need a 12% compound interest table. So I'm going to scroll down further, and I have 10% and 12%. So we got this. This is the 12% compound interest table. And we need to find out P given A factor for 3 time periods. So n, the time periods are in different rows. N is equal to 1 time period, 2 time period. We are interested in the third row, 3 time periods. 12% interest rate table, 3 time periods, and we want to find out P given A value, P given A, present worth factor, P given A, right? In row number 3 is 2.402, 2.402. So that's what we have here, 2.402. So we can take multiply each of these values by P given A factor 2.402, and then we can add these two numbers, because this is the we calculated the equivalent present value of this annual cash flow in time period 0, and this is already in time period 0, so we can add them. We can add these two numbers because one is P and one is A, so we cannot add amounts that are different letters P, A, F. So they should be in the same time period, right? Or we have to find out the equivalent values in the same time period, and then we can add all cash transactions in same time period. So here we are, we multiply that, and then we will get we can calculate the net present worth, right? So let me do just one calculation here. So I will take this 22,815 times 2.402. So that gives us 54,801.63 minus 50,000. That is the this value here, 54,801. That's the equivalent present value of the annual operating income. So that's a plus, right? This is total P value. So that's the total benefit of this machine in today's value, in time period 0 value. And we have to subtract the cost of the machine from that. So minus 50,000. So that's going to give us 4,801.63, or you round it off 4,802. So that's the net present worth. So same way we calculate that for each of the alternative machine, and you will see that the best option is the one that maximizes your net present worth, and looks like the lowest cost option, $50,000, and with a 22,850 in annual operating income, turns out to be best choice because it is NPW is 4,802, almost double of all of these other options. So no brainer, machine 1 should be, if I have to write, machine 1 should be selected. That is our final answer in this case. So I will stop here. Thank you.